This is code.org, and this is recursion. All right, in listprocessor.java, write method recursive reverse by translating iterative reverse method into recursion. So if you're ready for something difficult and confusing, ta-da, this is it, recursion. Now, that being said, don't be scared. It is complicated. It is frustrating. If you whip through this lesson in a few minutes, please go be the Googles for us. Like right now, drop out, go get a job, make $1 million and like fix Google, although Google's great. Maybe I shouldn't be pitching. Regardless, also don't drop out, go to college, get a computer science degree, or any degree, but computer science school. I'm way off course now, students. All right, so here's what we're doing. We have this iterative reverse. There's a for loop here. They want us to remake it with recursion. What is recursion? Recursion is a method that calls itself. Let me actually start recursive reverse. We need to be returning an int. So right away, I'm just going to throw in return new list. Otherwise, it will yell at me when I try to run anything, and I'll forget to do that if I don't. All right, and then what recursion is if this method called itself. So if I had inside of this method something like this. But mister, that's so weird. Why would you ever do this? It can be done in a way that is similar to a loop. It can be done in an iterative fashion. Now, before deep diving, I want to point out, this is confusing, but thankfully code.org gives us resources. Let me look at the last bubble. Boom. And now if you did all this, you might have to do version history and reset. But remember, right here, we have a loop. And this loop happens to be a while loop, but it will still be very similar. And here's the recursive method. Right? And we can see how they're using it to call upon itself instead of doing a loop. There's still a conditional, right? There's an if statement. A while loop has a condition in it. It's just a while loop and not an if. So if you're really stuck, please reference this. This is very much similar to what we will do. There's a few distinct differences, and I want to talk about them. So all of that being said, I know this is going to be an if because it's recursive. We're not going to use a loop in a recursive method. That would ruin the point. So I'm going to throw down an if. Boom, boom, boom. All right, what do I want in here? Now, what I want in here is the condition that I will be checking to either return my or end my loop, or the condition I'm going to be checking to make a change. Seeing that this has a return type, it is not a void, we are not going to want to return inside of an if because the method, the computer will demand that it have a return statement at the end outside of an if. Therefore, my if statement is going to be checking for the thing that means we're going to need to make a change. All right, so we are, and maybe I'm getting ahead of myself. Let's run what this is actually doing. Right, so here's the original list, and all it's doing is flipping it, right? It's reversing it. All right. So with that fancy knowledge, I don't know why the knowledge is fancy, it's what it is. Okay, so what do we want to know? We need to make sure that the new position does not go beyond the end of our array, right? So just like a for loop, just like here, they're checking, apparently they're iterating down, yes. They're checking if their index is less than 0. So we could do that. We could check if our original position is greater than or equal to 0. So let's do that, right? They're using the word index here, but index is set to be starting at the length of the list. And then they're iterating down. So let's say, we could do it the same way, actually. We could do, so if new position, if we want to start at the back of the list, I really don't like that strategy though, but that's fine. New position, if we're starting at the back of the list, no, I can't do it. Oh no, they are starting at the front. That's acceptable. All right, so we're going to say if original position, ooh, that was close. All right, so if the original position, as long as it is greater than or equal to 0, right? We can't go past the end of our list. As long as it's greater than or equal to 0, we want to go ahead and do some fanciness. I need to move up my recursive call up here. Okay, and let me get this all on the screen so we can actually see it. I'm going to do a bunch of returns here just so we can see it. Okay, and now what do we want to do? Well, if we need to flip the list, right, we're going to need to take whatever our new list that we are generating, the new list they are generating here. Watch, I'm going to just boop, boop, right? New list, new position. Now, what am I going to set here? Well, I'm going to do the old list and the original position, right? And the idea being is when I call this, my original position will be the end of my loop, right? So the original position when I call this is going to be this. It's going to be equal to the length of the list minus 1. The new position will be 0. So I'm taking the end of this original position and setting up the new position to be 0. So then in my new list, at position 0, the first run through, I'm taking the olds list, the very end of it, which I would have for original position, and slamming that into index 0. I then need to call this again. Now, there's a few ways to do this. I want students to keep in mind, original position then would need to be decremented, right? Like I said, we are starting at the end. Doing this decrements after the call, which is weird to say, but it does. This will seem like it's not working. If you want to do a minus minus down here, you have to do it in front of it, which says, hey, computer, make sure you take away 1 from this before you run this method. Maybe even a safer way, and this should work just fine. You could also, same with this, if you want to do plus plus. I like this method because it's more readable for students, honestly. I'm going to just do minus equals 1. You don't like it, you do it a different way. I like that. I think it's more clear on what is actually happening here. And then I need to go up by 1 there, and I'm going to call reverse and call the method again. Zoop, goes up by 1, joop, 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 adds. Now, the first time, like I said, I'll put in the original position of however long this is, 5, I guess, and the new position of 0. We go through this, they flip-flop it, and now our list is going to be the same. Our original position, like I said, we just subtracted 1 from it, so now it's 4. New list, and the new position, we just added 1, so it went from 0 to 1, and we'll populate the list. Finally, once this is no longer true, we don't want to call the method anymore. That would make an infinite loop type situation. So once this is no longer true, we don't want to keep calling our method. We just return our list. We are done. All right, let's see what I broke. Let's start I'm just going to run this. It will tell me if I missed something. Woo, so far so good. All right, and they were nice, I guess, and gave us a new list already. So let me hammer out what we need. All right, so I'm doing another list is equal to list processor recursive reverse, the original number list, and another list. However, we have a bunch more stuff. I need the original position and the new position. So the original position, like I said, I'm going to take my number list dot length and subtract 1 from it. And then the new position will be 0 to start. Whoops, 0 to start. And that's looking good. Now you want to print it like they do. And just for good measure, I might say something in front of this. That's looking all right. Let's see if I broke it. Quapow. And here's the original list, guys. We just flipped it. So you don't actually have to have this. I wanted to make my point, though. There is more than one way to do this and be entirely correct. To be clear, you might have your conditional on new position alone. You might have a nested if statement. There's more than one way to do this correctly. You just want to make sure that you understand this now, because it doesn't get easier. And if you don't understand this now, you'll get it. Look at this again and move on. Yeah, okay. Onward.